Good afternoon, third grade online learners. Today is January 11th, Monday, 2021. We have some kids back here today. We have, I would say, 3/4 of our class is back. 1/4 is missing. So we're hoping that those 1/4 eventually get back to us, and it might be a little bit of time. My third grade class is going to remind me to do a hello parade from my homeroom on Friday. Right, class?
Yeah.
Hopefully they remind me. We will try to do that on Friday. But we are switching topics. Last week we learned about energy and motion. And we are going to switch topics, but we're going to kind of talk about waves. So this is what we're talking about. Waves in the ocean, waves in other places, the characteristics of waves, what makes them up, and how you can measure them. Because we're not just talking about oceans now. We're going to talk about things electronically and things, all kind of different things with waves. So we are, if you have a book at home, we are on F14. If you do not have a book, you do not need it. You need your study guide. And you need to do your website summaries, and that should get you ready for the quiz. The book is nice, but it is not needed. Okay, how energy travels. Waves carry energy from place to place. Suddenly, the side of a mountain slides into the ocean. It's a landslide. The energy of the moving rocks and soil creates waves in the ocean. These waves reach a distant island, where they push water onto the shore. How did the energy of the landslide move through the water? It traveled in waves. A wave is a movement that carries energy from one place to another. Many forms of energy can travel in waves. Mechanical energy, heat energy, light energy, and sound energy can all travel in waves. The wave moves particles of water up and down. The toy boat moves up and down as the waves pass through the water. So we have wave particles and wave energy. Class, let me ask you this. Does anybody know what a gigantic wave is that forms because of an earthquake? Maybe out at sea, maybe in another country. Lydia.
A gigantic wave?
Yeah, there's a specific name for a gigantic wave. Miles. Tsunami. Did you know that too, Cora?
I know it.
Okay, a tsunami is spelled with a silent T. It's kind of weird.
Can I tell you
Now, just wait. You can tell me a funny story at the end of class. A tsunami is spelled Tsunami. So it has a silent T. It's not called a tsunami. It's just called a tsunami.
Where's the F? It was after the T.
Yep, the T is silent. So it's kind of funny looking word. Tsunami. Guys, they don't happen that often, thank goodness. And they happen way out at sea, underneath the ocean, or in another country, and they start pushing waves across the ocean to the continent. And when they come ashore, the waves can be as tall as a building. And they are very destructive. So we even have monitors in the ocean that will monitor, is a tsunami coming? And I remember watching with my kids at home, my own kids, a tsunami hit this resort and they didn't know it was coming, like the warnings didn't come quick enough. As tall as a building, you're laying on the beach and all of a sudden there's a wave as tall as a building. And my daughter said, I don't want to go to the beach anymore.
Oh, me neither.
I know, but I said to her, it's okay because this happens very, very, very rarely. Very rarely. And when it does happen, we have lots of warnings now. More so than when this happened in one place. It just boom, right into the beach. So it's not anything that you have to worry about. I'm not going to the beach. I'm worried about tsunamis. They're very rare, and we have warning signs now. And they really happen in specific parts of the world. I'm not saying they couldn't happen here, but I don't think we've had a tsunami hit the United States coast in a long time.
Does a hurricane ever, do they have warnings?
They do have warnings for hurricanes too. Yes, we have lots of things. We have satellites now that can watch storm patterns form, and they let us know, hey, it might be a good idea to get out, away from the beach, away from the shore, get somewhere because something bad's coming. And it doesn't always come though. That's like people are like, "I'll just stay. It's not going to come." If I'm on vacation and you tell me a hurricane's coming, I'm getting out of the way. Yes.
Have a tsunami ever hit the Pennsylvania?
A tsunami will never hit Pennsylvania because our state does not border an ocean. Now, it might hit New Jersey or Delaware or Maryland, or Myrtle. I just don't know of them hitting the East Coast. I think they're more prevalent in other parts of the world. Okay. Let's move on with this. Parts of a wave. Guys, between the two tops of the waves, it's called a wavelength. And then the bottom part of the wave that goes underneath, that's called a trough. And then a crest is the very top. So those are the main words we need to know. There's a couple other those. Crest, pitch, trough, vibrate, volume, wave. Measuring waves. All waves have traits that can be measured. The crest of a wave is its highest point. The trough of a wave is its lowest point. Waves with more energy have higher crests and deeper troughs. The wavelength of a wave is the distance between one crest and the next crest, or one trough and the next trough. Waves with shorter wavelengths have crests and troughs that are closer together. When the crests or troughs are close together, each crest is followed quickly by the next. You can count how many crests pass in a given time. This is the frequency of the wave. So guys, we can measure how strong waves are, their frequency, their crests, their troughs, and we can tell how strong that wave is, whether it's water or sound. It could be many different things, wavelengths of sound. On this page, we see a picture of a girl playing a guitar, and she is creating sound waves. I'm just going to do a little check on the time, and the time is still going, so we have some time to read here. Sound waves. Sound is a form of energy that travels in waves. Sound is produced when particles vibrate or move back and forth quickly. A guitar string vibrates when you pluck it. The string moves back and forth so quickly that it looks like a blur. The movement of the string creates sound waves in the air around it. The sound waves move out in all directions from the vibrating string. You can hear the waves as sounds. A sound wave moves particles of matter back and forth. It is like a spring that is squeezed and then released. As the sound wave travels through matter, particles of matter squeeze together and then spread apart. This happens over and over again as the wave moves away from its source. A crest is where particles of matter are bunched close together. A trough is where particles are spread farther apart. This happens over and over again as the wave moves away from the source. When a sound wave travels from its source, the particles that carry the wave do not travel with the wave. The particles move back and forth, but stay in the same general location. For this reason, a sound wave can travel only through matter. It cannot travel through an empty space. So guys, if you're in outer space and you make a loud sound, people aren't going to hear it. You get too far away from that person, they're not going to hear it because sound cannot travel through an empty space. Let me do a little time check here. And I think what we're going to do is save this page for tomorrow with this girl high and low sounds, loud and soft sounds. And then there is one more page, sound moves through matter, like it moves through water, and dolphins can communicate in the water, and so can whales. Probably some other fish that I can't think of specifically right now. But we will continue this discussion tomorrow. There's no journal entry today. So watch the video, study your study guide, and we will have another video tomorrow. Online learners, we miss you, and we will see you soon, and we hope everybody is okay in your house. See you tomorrow. Everybody say goodbye.